Hi guys, welcome to another lesson. Today we are going to learn how to graph quadratics from standard form. And I want you to see this is again our parabola. It's a U-shaped graph. So if you have a quadratic equation, it needs to be a U-shaped graph. It can look like this or upside down, but it needs to have a U-shape. There's a vertex. Vertex is a part of a parabola. Axis of symmetry, this is that line that goes directly through the middle, through the vertex of the parabola. So remember that. Remember that the parent graph has an equation of y is equal to x squared, or we can use the function notation and say f of x is equal to x squared. If we want the standard form of the quadratic function, standard form is going to look like this: ax squared plus bx plus c. And remember that we can plug in any numbers for a, b, and c. Parabola, it is a type of the graph for the quadratic functions. I've been using this word a lot. Now, before we were looking at the graph and we were finding the axis of symmetry. Today we are going to use a formula to find the axis of symmetry. I will go back to this on the second page, I believe, but keep this in mind. The formula is right here. The axis of symmetry, we know that that's the x value, and it's going to be described as negative b over 2a, and we will take the b is going to be the number that goes with x, a is the number that goes with x squared. Y-intercept of the quadratic function is equivalent to c. C is the term, the constant term, the number that will go by itself. It doesn't have any variables with it. All right, let's take a look at example 1. I am going to do both of them, and then you will have an assignment to do exercise 1, which is going to be extremely similar. So what we are doing is we are looking at the graph, and we are going to find the vertex. That's our first thing. So our vertex has coordinate, first make sure you say the x value, that's 2, and then the y value is negative 2. Always remember, you run before you jump, or in this case dive. We found the vertex. The equation of axis of symmetry, remember that is always the x value. Here's our axis of symmetry. So x is equivalent to 2. Y-intercept, we are going to give a coordinate. It's right in here. We are not moving anywhere on the x-axis, so our x is 0 and then y is 2. And that's all we were asked to find. Let's do another one. I want you to see this parabola as upside down. That means that if we were to find the equation of this parabola, the a would be negative. Okay, let's start with the vertex. We run 2, and then we jump 4. So the coordinates of the vertex 2 and 4. Next thing is our axis of symmetry. Again, this is my vertex right in here, and it's a line that goes through the vertex, so x is equal to 2, and then the y-intercept is right in here, I am assuming, so the coordinate of this point would be 0, negative 4. All right, you are going to complete exercise 1. You have 2 examples. You will do them exactly the same way I did those 2. And now we are going to go to the second page. And this is a little bit different because now notice we do not have a graph, but we still want to figure out what the axis of symmetry is, what the vertex is, and what the y-intercept of the function is. So again, make sure that when you are solving those problems, make sure you are looking at the first page where you had all the definitions. So the first thing is axis of symmetry. Definition said that axis of symmetry has an equation of x is equal to negative b over 2a. I would like to very strongly encourage you to list A, B, and C. So if you look at this standard form of quadratic function, my a is the number that goes with x squared, and that's 2. My b is the number that goes with x, and that's 4. And my c is the constant number that doesn't go with anything, so that's -3. Please be very careful with the signs. All right, so now let's take our axis of symmetry. Let's take our formula. The formula says that we need to take -b, so negative is in the formula, and then b is 4. And then 2 is in the formula, and a is 2. So -4/2 times 2. Oops, I did not do anything. Well, I will write this again. -4/4, and that is equivalent to -1. My axis of symmetry is equivalent to -1. So that is the first thing, I found that. Now, vertex. We know that the axis of symmetry is the x-coordinate of the vertex. So now we need to find the y-coordinate of the vertex. If you put -1 everywhere in place of x into our equation, and then follow all the order of operation and do only legal operations, then you will find your y-coordinate. So here we go. We have 2 times -1 plus 4 times -1 minus 3, and I forgot about one thing. Notice 2 times -1 squared, right? Very important. So let's see. 2 times -1 squared is going to give me +1. 4 times -1 will give me -4 minus 3. So I know that this is 2. 2 minus 4 is -2, and -2 minus 3 is -5. And notice this -5 is the y-coordinate of the vertex, okay? So you will have to do this again for the next problem as well. The last thing that we need to find is the y-intercept. I'm going to move my paper a little bit. And y-intercept on the first page, you had the definition. The y-intercept is equivalent to whatever the constant c is, and that is going to be the x-coordinate is 0 because you know you're on the y-axis, and the c for this one was -3. And we found everything we were asked for. The axis of symmetry is right in here. Vertex, we found the vertex, and the y-intercept is here. Let's take a look at another example. We will do the same thing for another example, B, and then also C, and then you will have 3 exercises to do by yourself. All right, so again, we are going to start with axis of symmetry. Again, there's a formula. X is equivalent to -b/2a. So again, I want to encourage you, take a second and list what a is. Notice there's no number. We know that that's 1, but there's a negative sign. Well, that's -1. B is equivalent to 6, and C is equivalent to 4. So now for my axis of symmetry, -b, that is -6 divided by 2 times a, which is -1. -6 divided by -2, that is going to give me +3. The axis of symmetry is at x is equal to 3. All right, the next thing that we need to find is the vertex. So for the vertex, again, because we did find the axis of symmetry, I know that that is the x-coordinate of the vertex. And now what I am going to do is I am going to take that 3 and plug it everywhere in place of x into my equation. So negative sign is right in my formula. 3 squared plus 6 times 3 plus 4. Make sure you follow the order of operation. Notice we are not going to square this negative sign, I'm sorry, we are just squaring the 3. So I am going to have negative 9 plus 6 times 3 is 18 plus 4. Negative 9 plus 18 is 9. 9 plus 4 is 13. And that is going to be the y coordinate of our vertex. All right, so notice I did put it in right in here. I know what is the vertex of my parabola. And the last thing I need to find is the y-intercept. And again, I want to remind you, on the first page there was a definition that said that the y-intercept is whatever the constant c is. Why? Because if you plug in 0 everywhere in place of x, c is the only thing that is going to be left over. So c in our case, c is equal to 4. So the y-intercept is going to have coordinates of 0, 4. Done and done. And now the last problem. Again, this one is a little bit different because notice it's missing its middle term. So there's nothing with x. So what I'm going to do is I'm going to write this a little bit differently. I am going to say, well, this is equivalent to x squared plus 0x minus 9. 0x is a term that is canceling. So 0 times x is 0. So notice that those two are equivalent. But now what it helps me with is for axis of symmetry, the formula says that x is equal to negative b over 2a. It's much easier to see what the b is. So notice a is equivalent to 1, b is equivalent to 0, and c is equivalent to negative 9. If I plug in my values into the formula, I will get that x is equal to negative 0 divided by 2, and we know that that's 0. So axis of symmetry is at x is equal to 0. For the vertex, again, I am going to do the same thing. I know that this is the x-coordinate of my vertex. And what I'm going to do with the 0 is I'm going to plug it in everywhere inside of my formula. So I will have 0 squared minus 9. And that is equivalent to negative 9. I will put it as the y-coordinate of my vertex. And then the last thing is the y-intercept. I know that this is the c. c is equivalent to negative 9. And the point is going to be 0, negative 9. Take a look. This is a very, very interesting parabola. If you think for a second about the transformations, this is a parent graph of a parabola that is moved down 9 units. So if you think about the graph very quickly, parent graph would be here. I am moving my parabola 9 units down. So I want you to see what is happening. The vertex is at 0, negative 9. That is also your y-intercept. And the axis of symmetry is right where x is equal to 0. Okay, so think about the transformations, think about how that connects to the previous lessons, and make sure you give me some good quality work. Make sure you complete all the problems that I did not. So you have exercise 2, 3 problems there, and 2 problems on the first page. Make sure you have fun with that.